sorry for the glitches. I'm Jamaluddin Jami, Head of Enrollment at Universal College, Bangladesh. I'd like to have the pleasure to welcome you all to the very special session today. Monash UCB exclusive workshop preparing future engineers for digital transformation. And to conduct the session, we do have with us today Dr. Amin Talei, Associate Professor, Civil Engineering. The Head of Civil Engineering Discipline of Monash University, Malaysia will be conducting the session today. And also we do have with us Mr. Aaron Ten, Manager International Recruitment and Development, Monash University, Malaysia. And for the participants, you will be receiving a joint certification from Monash University, Malaysia, as well as Universal College, Bangladesh, upon completion of this session today. Before you start our session, I would like to have the pleasure to answer a very important question because some of you may have in your mind what is Universal College Bangladesh and what sort of relationship we do have with Monash University and Monash colleges. To answer your question, Monash College, Universal College Bangladesh is the exclusive partner of Monash College Australia and is the only Ministry of Education approved international education provider right here in Bangladesh. So from now on, students can jumpstart their journey to Monash University immediately after their OAS and A levels by joining Monash programs right here in Bangladesh at UCB. Students receive the same global academic curriculum, 100% guaranteed entry to Monash University, and extremely cost-effective tuition fees. So Monash University, if I talk about the ranking of Monash University, is a World 100 top ranked university. What about the ranking? You just name it. You will find Monash within top 100. And if I want to talk about the programs that we offer at UCB, the programs we offer, Monash University Foundation Year Program, which is equivalent to Australian Year 12. It means right after your O level, you don't need to go for A level. You can join Universal College Bangladesh by joining Monash University Foundation Year Program. That will give you 100% guaranteed entry to Monash University, Malaysia, and of course Australia. And if you want to go to Malaysia, Mr. Aaron is here, and he will be giving a brief idea just after my introducing about the beautiful, amazing campus of Monash University in Malaysia, and also a significantly less tuition fees and scholarship opportunities, of course, he does have today. We also offer Monash College diplomas in applied data science, business engineering, and information technology. So these diplomas are equivalent to Monash University first year. It means after year A or AS level or MAFI, you join us, you complete 1 year Monash College diploma. That will give you 100% guaranteed entry into second year at Monash University, Malaysia or Australia. And before we move forward, let me bring to this virtual stage a very important person, Mr. Aaron Ten, Manager, International Recruitment and Development, Monash University, Malaysia, to say a few words for our Bangladeshi students.
Good morning, students, and thank you and welcome to the workshop sessions today. My name is Aaron, and today I'll share a piece of very important information with you. And this information is vital to help you in selecting the right universities, and this in turn will ensure that you have a bright future. Now, what if I tell you that you can get an Australian bachelor degree at a fraction of the cost of studying in Australia and still be close to home? And best of all, an uncompromised Australian education system that meets the standard of Australian qualifications frameworks. Three things. I will share three things with you today. First, why study at Monash University in Malaysia? What are the courses offered at Monash University in Malaysia? And thirdly, how much does it cost to study at Monash University in Malaysia? Why Monash in Malaysia? First and foremost, we are the largest university in Australia. And as mentioned by Jamal, we are always ranked among the top 100 universities in the world. According to the latest QS World Ranking, we are ranked 55 in the world, and we are part of the prestigious group of 8, the top 8 universities in Australia. Many do not know that Monash has presence in 3 continents of the world. Apart from the 4 campuses in Melbourne, Australia, we also have a full-fledged campus in Malaysia and 3 other research collaboration campuses in China, India, and Italy. A fourth research collaboration campus has just opened in Indonesia earlier this year. Another questions you may have in your mind is your degree certificate will be identical to students who completed their studies at Monash University in Australia? Yes, it is. It does not matter which campus you complete your study at, you will all get the same degree. Your degree will be awarded by Monash University. To put it simply, when you are studying at Monash University in Malaysia, even though you are physically in Malaysia, you are not in a Malaysian university. You are inside an Australian university. The medical degree completed in Monash University Malaysia campus is also officially recognized by the Medical Council of Bangladesh. And you will be on your way to be part of the more than 350,000 alumni worldwide. And best of all, an authentic Australian education. Now, second, what are the courses offered at Monash University in Malaysia? But before I share the courses available at Monash in Malaysia, I would like to show you the pathway available to you to get to Monash University in Malaysia. If you have a Bangladeshi HSC, you will have to enroll into the Monash University Foundation Year, or in short, MUFI. MUFI is a one-year program, and it is available at UCB in Dhaka. Once you have completed MUFI, if you miss home, you can still stay on in UCB to do the Diploma Part 2. Upon completion of the Diploma Part 2, you can gain entry into the second year of the bachelor degree at Monash University. How does this work? You have to get in touch with University College Bangladesh in Dhaka. There are 7 schools at Monash University in Malaysia. They are the School of Arts and Social Sciences, Business, Engineering, IT, Pharmacy, Medicine and Health Sciences, and the School of Science. We have a wide variety of majors and specializations which are in demand, including courses like psychology, business, engineering, computer science, data science, artificial intelligence, robots, civil engineering, medicine, pharmacy, and the sciences. Our most sought after and most competitive courses, of course, is the Bachelor of Medical Science and Doctor of Medicine, Bachelor of Engineering with honors, Bachelor of Pharmacy, as well as Bachelor of Business and Commerce. We are, after all, the highest ranked university you can find in Malaysia. And lastly, how much does it cost to study at Monash University in Malaysia? Our bachelor degree fees ranges from 40,000 to 60,000 per year. The medical degree, of course, is more expensive. It ranges from 120,000 per year or more. Living expenses will set you back around 2,500 to 3,000 ringgit a month. The table shows you an estimation of the monthly living expenses of our current students in Sunway City. That's all my short introductions for today. I hope you have gained some insight into Monash University in Malaysia. If you would like to take a tour of our beautiful campus in Malaysia, you may want to take a snapshot of this screen. Just visit the link below the screen and you will be able to have a virtual tour of all the facilities in Monash University, Malaysia. Thank you so much, and back to you, Jamal.
Thank you. Thank you for your wonderful presentation. We know a lot of master's students are here, and if you are interested for master's programs, we do not offer any master's programs in Dhaka, so you can directly go to Malaysia. And of course, you can come to our office. We do have a sister concern, another concern, Educo Pathway. The representative of Educo Pathway will be helping you to complete the admission procedure and also helping you, guiding you if you have any scholarship opportunities or not. So thank you very much. Mr. Aaron Tan, for your wonderful, brilliant, informative information that will of course help. Now this is the time, this is the moment to start our, the awaited session, exclusive workshop, preparing future engineers for digital transformation. And to conduct the session, I would like to have the pleasure to introduce Dr. Amin Talei, Associate Professor, Civil Engineering, the head of the Civil Engineering discipline, Monash University, Malaysia. Sir, the floor is yours.
Thank you very much, Mr. Jamal. Okay, very good morning to all participants in Dhaka. Unfortunately, I haven't had the chance to be there. Once I was about to be in Bangladesh, but unfortunately, because of some changes in the plan, I couldn't. So hopefully in the near future, we can visit you there. So today I'm going to have a presentation to introduce the digital transformation first. Then I will introduce a bit about the research, or let's say the education aspects in engineering that are relevant to digital transformation in Monash, Malaysia. And then after that, I will have also a brief introduction of our school, perhaps with a bit more details about the facilities, the things that we can do there. And that will actually conclude my presentation. So let me share my screen. I have some slides to go through. Okay, I hope you can see my screen. Is it fine?
Yes.
Okay. Yeah, perfect. Okay, so as mentioned, my name is Amin. I'm the head of civil engineering program. I'm a PhD holder from Nanyang Technological University of Singapore. It's about 9 years that I'm in Monash, Malaysia. So it's a very pleasure for me to be here with you guys. So let's start with a very general introduction to Industrial Revolution. I'm sure you have heard it because the digital transformation is relevant to that. So as you may have heard, we are now in the era that are facing the fourth industrial revolution, which is generally known as digital transformation. So let's have a quick look of what has happened in the past. So the first industrial revolution officially is tagged to 1765, and it is known as the era of mechanization, the time that human civilization has started to utilize, or let's say invent and then utilize, several types of machines. And I believe that the master piece of their invention was the steam engine, happened in early 18th century, around 1712. But it took about like 5 decades to gradually become well advanced to be used for industries. Or in other words, I can simply say that to become ready to be industrialized. So 18th century, in the middle of 18th century onwards, we had a lot of changes in human civilization because of these inventions, different types of machines to help us produce different type of products. And then after that, almost 100 years later, in the mid, or let's say in the second half of the 19th century, we had the second industrial revolution with the invention of electricity, the progression in the oil and gas industry, a lot of chemical synthesis came into the picture, and the invention of telephone. So all these actually helped people to actually have a better lifestyle, have more products, and have things being actually produced in a more industrialized way rather than the manual. Again, about 100 years later, in 1969, the third industrial revolution happened. This one was the era of electronics, computers, telecommunication, and so on. And of course, there are some other technologies that came into the picture. For example, harvesting the nuclear energy in order to generate electricity. Biotechnology had a lot of progression. We gradually improved in computer science, a lot of programming, or let's say programmable logic came into the picture, robots came into the picture, and gradually a lot of industries started to adopt computer-based works, and the usage of robots as part of the production became quite routine. So by the end of 20th century and the beginning of 21st century, we had a lot of industries gradually moving to robotics and reduce the number of manual manufacturing parts. So the question comes in, okay, seems that we are in a very good place. So what else is remaining that we are expecting the fourth revolution to give us? Okay, around year 2000, there was a boost in the usage of internet all around the world. I'm sure those who are like in my generation, they know what I'm talking about. I remember the time that I was in bachelor level, studying around like late 1990s, the PCs that we had or the usage of internet was, honestly speaking, very low level. The speed is very low. Internet was through these phone lines, and actually we had very limited access. Then suddenly around 2000 onward, the progression was super fast. I remember the amount of money that I spent to have my first PC, which was just a very simple computer that I think now my mobile phone is much faster than that. Same amount of money, like 5 years later, I purchased a PC with almost like 10 times bigger RAM, 10 times bigger hard disks, and so on. So you can see how fast the progression was within just few years. So when all these things happened, around 2011, the discussions came into the picture that, okay, now that internet is that actually advanced and almost all around the world, people are using that, perhaps it's the time to actually utilize it. The technologies related to internet and computer and programming, artificial intelligence, and so on, to make another revolution in our industry. And that's the place that the fourth industrial revolution came into the picture. So it is talking about Internet of Things. I'm sure you have heard about it. I'm going to explain a bit more. Artificial intelligence, nanotechnology, quantum computing, the fifth generation of wireless technologies, 3D printing, and of course, autonomous vehicles. These are some examples of the things that in the past 10 years, a lot of money have been invested in the research part. And we can see that gradually the products of that are coming up, and there is a huge move. And I believe during the COVID-19, we get the chance to see how these technologies can help us to actually fight some of the things that can happen to us as one of the living creatures on this planet. So the Industrial Revolution 4, that we know it as 4.0 because it may have some sub-branches in the future, originally introduced 9 approaches or technologies, and all of them are somehow related to computer or, let's say, internet. I just read through them. So for example, big data analytics, cloud computing, cybersecurity, system integration, robotics, augmented reality, additive manufacturing, or what you have heard it as 3D printing, simulation, and finally, Internet of Things. So these are the technologies that are listed under Industry 4.0 and are believed to be the solutions for a huge transformation in any kind of industry. So originally they were thinking that perhaps manufacturing is the one that will go first, but now after almost 10 years from the first discussion about fourth industrial revolution, now all aspects of the fields, not only manufacturing, is affected. And it's actually moving towards that transformation. So in countries, different countries actually, like developed and developing countries, they're all planning for having a fast transformation towards that. Malaysia started about 3 years ago, and officially the first manual from the government came out about a year ago. Australia started it in 2017, and they are quite ahead in the program for all these transformations. And as you can see, in a country like Malaysia, they have added some more components to this industrial revolution. For example, here you can see the artificial intelligence as a separate component of those approaches. And also you can see advanced materials. So they believe that these two also are like sub areas, or let's say side dishes of the main 9 technologies that I mentioned earlier. So each country may have some additional components to that. Okay, so the question is, what are the potentials? So all these technologies look very fancy, the names are nice. Okay, what they can give us, what they can offer. So the whole idea is that all these technologies can help us to have increased productivity, increased flexibility, increased speed, and of course, increase quality. And that can happen with the offers that these technologies can have for us. For example, optimizations, automation, or real-time monitoring, usage of internet to actually closely take care of whatever we produce from the first point to the last point. The better maintenance that we can have by the help of all these technologies. The machines that can be intelligent, no need for human to intervene or manually change them. They can actually, you just need to program them and they will do the job for you. They make all the decisions in the best way. And of course, production simulations and so on means that before even you do something, you can do many things by modeling and simulation to just predict what is going to happen. And then you start to spend the money to build something. So all these items that I mentioned can eventually provide us a better working condition, a better safety, a better collaboration between people and also the components of the work, and of course, bring us innovative capabilities. And at the end of the story, my general belief is that all these things should be able to help us to have a better environment protection, because that's the only place that we have to live, our planet. And eventually, based on what you have heard, you know that climate change is there. We as humans have also created a lot of pollutions on this planet because of all these industrial revolutions. Now is the time to be very careful about what we have as our home, and we need to take care of that. And all these technologies of fourth industrial revolution are helping us to actually achieve that main goal. I'm going to elaborate a bit more on it. So let me explain a bit about some of these approaches. I purposely have chosen those that are most relevant with engineering. So for example, artificial intelligence is one of them. And you know that it's a branch of computer science. And the main goal of this branch is to learn from our brain, human brain, and then try to emulate it, try to artificially reproduce it, okay? So it's quite old in the picture. I think it started around like 1950s, 60s. On paper, we had a lot of things. The first generation of PCs came into the picture and a lot of things have been done. But the main progression or advancement in this area has happened around 1990s onward. It's about like 3 decades. So AI or artificial intelligence has some features that are very useful. First, they're data-driven, meaning that they can learn from the data and they can see some hidden information in the data that we as humans may need to spend hours or millions of hours to just find it. And these computational methods, by the fast computational tools that we have, can do this job for us in the matter of few seconds sometimes. They are adaptive. They're capable of being adaptive, means that we can program them in a way that they learn and they improve. They are definitely helping us in autonomy. And of course, they are purpose-driven. You can define them to do significant actually jobs for us. So in general, the concept behind them, or let's say the problems that they can address, they are all about reasoning, knowledge representation, planning, and learning. So these are exactly the things that we need when we want to produce anything or we want to do any job. And there are a lot of computational intelligence and soft computing tools, or let's say algorithms. I'm sure you have heard about like artificial neural network or fuzzy logic or evolutionary computing. All these things, they are learning from human or other creatures to actually emulate the process that they do and then utilize it in the problem solvings that they have. You can see some names here which may be interesting to you. For example, ant colony. I can just briefly explain what is that. So ant colony is basically a kind of optimization method that tries to learn optimizing a problem in a way that ants actually do that. Because ants, you know that when they are working, they're like small creatures. Each of them perhaps has a very little brain or little decision making, but the group of them can do fantastic jobs together by the communication that we have with each other. They do things in a very optimized way, much better than us. So these algorithms try to learn how they do that communication and then apply it in the problem solvings that we have. So, and we have a lot of other examples like that. So the second one that you may have heard also about it is the Internet of Things, or IoT. It is already in place. I'm sure some of you may even are using it now. For example, our mobile phone, when we link it to some other tools, our TV, sometimes our car, or some lighting in our house, and so on. They are like simple examples of normal usage of IoT. But in Industrial Revolution 4.0, we are talking about much more advanced version of that. I can give you some futures of these type of applications. Imagine that, for example, in a water supply of a city, you don't need to manually control anything. So the system, based on the data that comes from the sensors that are installed in households, in the streets, in the water plants, and so on, can easily digest the information and decide whether we need to supply more water or less water. If anything happens, what should we do? So all these things can be actually decided based on the huge information that will be collected by so many sensors here and there in all equipments, in all facilities, all households. So this is a very simple example of that. So what is the process in IoT? Sensing, first of all, means we need to sense something. So that's why sensors are very important in this. And then we need to communicate the information that we have collected. Then we process it. And then we offer a service. And finally, that will serve our society in a certain area. The third one is remote sensing. Now we are in the era that we can actually measure things from far distance. We have satellites that can give us the detailed information about rainfall, about soil moisture, about traffics in the streets, and so on, just up in the air. And not only that, we have drones and airplanes, unmanned airplanes, and so on, that can do some of other things like that. For example, the photo here shows catchment monitoring for environmental protection just by help of drones. So you can send them, going to very remote areas that people cannot go, and provide us all detailed information. So remote sensing is also another interesting feature that we have nowadays. The next one is big data. So big data is also very important because now we have a lot of gadgets all connected. They're all like computers, they're all connected with internet. So all of them are a source of a data. And now we are dealing with a huge amount of data that simply we can call it big data. And analyzing that, understanding the data, and using that is not easy. It's a challenge, and of course it's moving on. Again, to give you an example, nowadays to just predict flood, or I don't know, I'm just giving examples on my field, which is water engineering. So for example, imagine flood. So in the past, the ways to just see whether flood is coming or not was measurement in the rivers. Or for example, the actual flood needed to happen, or the rain measurement were helping us. But now a tweet that someone actually upload, or a post in Instagram or in Facebook, can be additional layer of the data for us to understand where are the affected areas, which areas are now facing flood first, for example, what is the severity of that, and so on. So we have a lot of multiple layers, I would say, of data that are available. And so far we haven't used them for different purposes. Now it's the time to actually think of that and come up with technologies that can process that. So what are the big data challenges? We need to capture the data. We need to store it because it's huge, need a huge space for storage, need analysis, need search, need sharing, need transferring. Sometimes you need to visualize your data and then updating it. And of course, one major challenge is privacy, because if we are getting access to those type of data, we are prone to violate privacy of people. For example, if someone wants to actually explore and get some data that come out from people, there are layers of privacy that may be affected. So these are the challenges that now we are facing. And finally, virtual or augmented reality. This is very new. In the past 10 years, a lot of progression has happened in that. I'm sure you have seen at least videos like that. For example, some brands have started to actually do it, meaning that if you want to buy a sofa for your house, you don't need to go and see it in place. You can have a gadget and even virtually place it in your hall to see whether you like it or not, how much space it takes, whether the column matches with other things that you have, and so on. This is now available. So I'm talking about user-friendly interfaces that can come into the picture for any kind of businesses. And then not only that, we can actually use that for modeling and helping our decision makers. So engineering has a lot of applications. For example, in construction industry, we can use that. If you want to have maintenance of a pipeline, you don't need to dig the ground. If there are certain information provided, you can just virtually watch what is happening under the ground and so on. So there are a lot of applications. And the very most important one that nowadays has become very significant is the training, the virtual trainings. So in Monash now we are doing that actually. For example, for medical school, you don't need to really open the stomach of a patient to see what is inside. You can virtually do that, at least for the training or education part of it. Or for example, as a civil engineer, if you want to have inspection of a safety of a building, you can virtually learn how to do that. You just put this gadget on and you can go in a 3D environment, surf around, check things, answer some questions, inspect it and come out, even without being in the original building. So you can see how these things can help us to train our experts before they are practically going to actually do the job, whatever it is, either it is engineering or medicine or whatever. So let's go to Monash and see what are the things that now we are doing related to this IR 4.0. I'm just giving examples here. For example, our team in civil are working on smart buildings. And when I say smart buildings, it is talking about automation, integration, and of course, intelligence. So it is about how we can minimize the cost, how we can actually be mindful about our environment when we are using some material to build something, and how we can efficiently utilize material and energy in our building in order to serve the sustainability of our planet. So all these things together, we know it as smart buildings. So it is talking about the design, construction, and then the usage, or let's say the operation of the building. There are a lot of studies, for example, our transport people working on the ways that we can actually have a better traffic control. If it is about a house, how to manage the parkings. For example, I'm talking about the building, let's say, and so on. Or our structure guys talking about how we can have a better construction material and so on. Our robotic people, example of what they do is soft robotic. They're robots that are designed to work like our human finger. They are soft. They can touch delicate things, like, for example, picking an apple or a peach from a tree without damaging it. Because in the past, the robots were all like metal stuff. Now they can be soft robots. They can do the job like our fingers, for example. So it's a huge research area, and many people are working on that in our Monash, Malaysia. Okay, another example, crowdsourced data. So for example, in, again, civil engineering, we are working on methods to actually utilize people information coming out from mobile phone or tweets or the posts that they do in order to have additional layer of information related to flood warning systems. We have done some studies in Subang Jaya, in Malaysia, in KL, and so on, in order to explore the possibility of usage of that. So it's a related material to AI and big data. Our ECSE guys, electronic and computer science, they are working on intelligent lighting. So you can see different aspects of that. We are now working on areas like communicating through light in a very more advanced way. the wearable sensors, especially usable in biomedical engineering. Or for example, imagine that we have a smart lighting in, let's say, educational area that depending on the situation, number of people, the hour in the day, the type of activity that you do, it decide what type of light, with what power, which color is necessary. So it's a kind of a smart lighting system and some other aspects of it. Or for example, horticultural, which is working on having light as a kind of artificial source of lighting to have plants indoor. So you are somehow emulating the sunlight with the proper energy and color. And autonomous vehicles. This is in the news. I'm sure you have heard about like Tesla car and so on. So there are a lot of research going on in Monash on it. There are a lot of studies on how we can have these autonomous vehicles in the streets in order to safely have them without affecting the traffic, without having danger for the pedestrian and so on. So it's a very live research area in Monash. And finally, digitized construction. I gave this example before also. So for example, we have the usage of virtual reality for training, safety inspection, construction accuracy, and so on. And we have this technology, know it as BIM, B-I-M, Building Information Model. So unlike the past that we had everything in paper-based drawing, now everything is digitized. And we can have multiple layers of information on our computer, and then we can have a look on it in a 3D way. So without even building anything, you can see whether a pipe that's supposed to transfer water, whether it is intersecting with, for example, a column by mistake. And if that happens, we can actually revise our repositioning or the piping or the columns, for example, to make sure that things can move on. So it minimizes the errors a lot. So we actually check everything in advance before even we touch the land and start any construction. So this is something that is moving on. It's almost a decade that a lot of research have been done on that, and it's now getting more and more popular in some countries. For example, in Singapore, having BIM for all buildings is compulsory. Malaysia is moving towards that, not compulsory yet, but they are moving towards it. And I believe that's the future of construction industry. So it means that without BIM, you're not allowed to do anything, because that saves a lot of money, saves a lot of efforts and time as well. Okay, so now the question comes in that as future engineers, what do you need? First of all, of course, when we are talking about new engineering world and all these fascinating technologies that can be used, or let's say that can be explored with proper skills. So I categorize the skills into two, the technical skills and the soft skills. The technical skills, of course, it needs you guys as the future engineers, whatever field you go, doesn't matter, you need to be good in data analysis. You need to be good in model-based engineering, because everything is going to be simulation computer-based from now on. So we cannot skip that anymore. And of course, being ready to work with digital tools. All technologies are going towards that. So the era of manual way of doing things is gone. So it's now the digital transformation. So we need to actually familiarize ourselves with all those gadgets. And then the softer skills, working in multidisciplinary teams. Civil engineers cannot work with themselves alone. They need to work with mechanical, electrical, robotics, and so on. So now it's a time that it's almost like a decade that we are there, but getting even more and more complicated, that you need to understand that that's the time of multidisciplinary teams. So you cannot work alone anymore. The second point is working in hybrid teams. Hybrid teams means that you may need to work in Bangladesh with someone based in US, another colleague of you or team member is working in Malaysia, the other person could be in Sweden, for example. So these hybrid teams, people that are in different locations, different time zones, different expertise, and having access to you in different ways. So, and still you are a team, you are supposed to work together. That's that is already a necessity for the future world of engineering. And finally, virtual environment. I believe that's also another thing that is inevitable. So very soon we will see the usage of these virtual environment in almost every field. I just gave some examples in medical and also medical usage and in civil engineering, but there are other areas that are moving towards this virtual environment, especially for training and safety aspects first, and then perhaps for other things like decision makings and so on. The second point, new engineering world also need new engineering education and training. So that means that in the universities, we cannot just simply stick to those older stuff that are written in the books or some older stuff that are available in softwares, for example. That one is gone. So it's the time now to integrate a lot of other components into those traditional or conventional information. And what are they? Of course, artificial intelligence. I can simply say that in another 5 years, having no information about artificial intelligence for engineers means someone who cannot work with a calculator. They're equivalent. Yeah, I mean, very soon you need to have the basic knowledge of artificial intelligence if you want to work as an engineer. Advanced computing techniques, smart sensing, handling data, being well-versed with visualization techniques, being well-versed with Internet of Things, which means sensor-based type of work, and of course, again, virtual augmented reality. These are the components that should be integrated into our education. So you need to actually learn about them during, let's say, engineering course, at least have some familiarization level, being familiar with that. And then, of course, you can become expert in certain number of them. The third one, for engineering world, you need to have new engineering work environment as well. So what are they? Definitely the organization, laws and regulation need to be revised, and that is actually happening now. Many countries have started to look back to what they have and try to revise it and match it with what is happening in the digital transformation. Flexibility must be there. You cannot force people to be in certain places at certain time anymore. I believe the future will become much more flexible, means that you can be anywhere at any time zone to be involved in any project. And you need to also understand that any kind of tools can be involved. So flexibility should be there. If not, you cannot survive. And of course, collaborative environment. People need to collaborate more compared to the past. So those individual or let's say traditional way of handling things is gone. So we need to actually move towards collaborative environment. Okay, good. So what is the ultimate goal? As I said earlier, sustainability. These are the 17 UN Sustainable Development Goals defined a few years ago. And some of them are going to be achieved if we are having a successful digital transformation. I just highlight some of them that are obviously going to be achieved, like better water and sanitation, better energy production and consumption, or decent work and economic growth, for example. Industry innovation will be there. Sustainable cities and communities will be there. Consumption becomes more responsible and productive. And of course, we are serving our climate more than before because of all these technologies. So a bit about our school. I believe Aaron gave some information, but let me repeat. These are the general rankings of our university, as Mr. Aaron mentioned. So we are now ranked as 55 in the world. And in Malaysia specifically, we have some other rankings based on Malaysian government. And if you want to look into specific fields, which is technology and engineering, which is relevant to us, you can see some detailed information in the right column. For example, a bit more detailed ranking of our programs. For example, our chemical engineering ranked 29th in the world. Our civil is ranked 21st in the world, and so on. So you can see the rankings of specific areas and some other recognitions that we have by, like, for example, Engineers Australia, Board of Engineers Malaysia, IChemE, which is from UK, and so on. Okay, so this is the history of our campus. We started in 1998 with mechanical and mechatronics, which some people call it robotics. And then gradually electrical engineering, chemical, civil, and most recently software engineering came into the picture. We have bachelor degree, we have master and PhD by research as well. And currently we have a very active team of postgraduate students, master and PhD, working in our school. As Mr. Aaron mentioned, we are offering undifferentiated degree, means that all our teaching content and assessment is parallel with Australia, happening at the same time even. Will be cross-marked with the lecturers in both campuses, and we are getting same degree. Eventually, one degree will be given to all the students. We are having compliance with Board of Engineers Australia and Malaysia, means that the degree will be recognized after graduation. They can register as graduate engineer and immediately start work. And we have some other activities like engineering and IT leadership program, undergraduate research opportunity program, and so on, which are like extracurricular activities for those who are in the School of Engineering. And this is our team. The top two rows shows the management team. In the middle, we have some senior academic staff. And at the bottom row, we have the course directors for different different engineering programs, civil, chemical, mechanical, electrical, and robotics. I just go through fast because I don't want to take much of your time on these matters. So our experts are working on very high-end actually research areas. And finally, these are our lab equipments, basically. I'm just giving some examples from different fields, like virtual reality lab, our structure lab, robotics, and finally, the other one about nanotechnology. Okay, thank you very much. I hope I didn't use extra time too much. Sorry for that if it is. Okay.
No,
so
you didn't. Thank you. Thank you very much, Dr. Amin Talei, for your wonderful, marvelous presentation. Now, we'll be taking very few questions. So participants, if you have any questions, you can write on chat so that we can convey it to our research person and he will be answering. If you have any questions, you may write on chat. Okay, no question.
Don't be shy. This is what we always say to our students. Don't be shy. Ask if you have.
Okay, we do have one question. Do you think the pathway is sufficient? Actually, for pathway, Dr. Amin Talei, basically it is regarding enrollment. So Mr. Aaron, I can answer. Yes, of course, we need to know your destination program basically. If you are a student of HSC, I mean from our national curriculum, and if you want to go for medical science, of course, you must go with the pathway, I mean foundation year, that will give you right path. We need to know detail of your education background as well as your future destination. Only then we can guide. Right, Mr. Aaron?
Yes, that's correct. So whatever degree you wanted to go into at Monash University, please make sure you speak to UCB. They will make sure you have the right combination of subjects when you are doing your foundation or diploma at Monash.
Okay, I can see, yes, after O-level. Yes, after O-level, you can start your foundation year here at UCB. Pathway is enough. And it is Australian year 12 equivalent. So that will give you 100% guaranteed into first year. What is A-level requirements for mechanical engineering?
Yeah, I think
Yes.
I can take that.
Yeah.
So if you have a Cambridge A levels, then you will need 11 points. If you took Pearson A levels, then you need 12 points. So these 12 points is calculated from a maximum of 3 A level subjects. And you must have a mathematics and a chemistry or physics.
In year 12.
Yes.
This is for Professor Amin Talei for you. Sir, do you suggest future engineers having a degree minor in business related studies or
Okay.
or only some basic knowledge is enough?
Okay. I need to answer this question in two different ways. I mean, first of all, of course, some people may have interest in business. So that's why perhaps you are asking that. But I would say that interest can be entertained in our leisure time in a different way as additional skills always. So that can happen. The second aspect that I need to answer is the accreditation bodies, or let's say those engineering bodies that eventually are supposed to register you as an engineer. Based on what I know, in most countries, there are certain constraints on that, meaning that the number of years that you study in the engineering field, the number of units that you pursue matters. So eventually, if you go for minors, means that the weightage of non-engineering stuff goes high in your degree, there is a chance that they don't recognize your degree as engineer. Still, your degree will be recognized to work, but not as engineer. They may ask you to do additional study, let's say a master's degree in engineering, to just become registered as a normal bachelor engineer. So I would say it's good to be wise about that, perhaps explore the possibilities and then decide about it.
Thank you. Thank you very much. About enrollment, what is the foundation year equivalent to in terms of Cambridge A levels? Aaron, do you want to go or I can?
Yes, I think, I'm sorry, can you repeat the question?
Yes, about enrollment, what is the foundation year equivalent to in terms of the Cambridge A levels?
I don't really understand the questions actually.
Okay,
Jamal.
let me go through. What happens? O level is recognized year 11 equivalent. So year 11 O level, year 11, A level year 13. For university entering, what happens? You need just year 12. So after O level, that means after year 11, once you do 1 year foundation year program, Monash University foundation year, it means you are qualifying, you are having Australian year 12 equivalent degree. It means equivalent to, in other sense, A level. You don't need to go for A level. After O level, you can come for foundation year program. It means you are clearing your university degree requirement qualifications, that means grade 12, year 12. So that's enough. And that will give you 100% guaranteed entry.
Yes, that's correct. Yeah.
Could you please translate the point into grades? Example, A stars, A stars, A, triple A.
Yeah, okay. I think I can do that. So yeah. It's really simple. In A levels, you have grades like A, B, C, D, E. That's 5, 4, 3, 2, 1. So an A will give you 5 points, B will give you 4 points, C 3 points, and so on. Yeah.
Okay, when should I apply after AS for Monash University?
You can start your applications right after you have gotten your AS level results.
Okay, what do you enjoy most and least about engineering? What do you enjoy most and least about engineering?
Okay, I personally think that the most enjoyable part of engineering is creation. You become a small god. That's, I think, the most fantastic part, because you are creating new things. And I think that's really enjoyable. You will love seeing that. And the least part of it, okay, it may be tough sometimes because we are dealing with numbers, with lot of physics and mathematics. So if you don't like it, perhaps that becomes maybe problematic. Yeah.
Okay. Most probably today was the attractive subjects. A lot of available students are here. That's great. Any more question? We cannot see any questions. So I think we're done with the question answering. Thank you. Thank you very much, Dr. Amin Talei, for your wonderful presentation. Any final note for our Bangladeshi students?
Thank you very much. I really also appreciate having this chance to be with you guys. I hope you have enjoyed. My final note is that, yeah, actually we are moving towards, I would say, very interesting era very soon. And I believe especially COVID-19 was a kind of facilitator to moving faster towards this transformation. So let's hope to see many of you guys in engineering very soon. And don't be afraid of this transformation, because transformations always may look challenging, but eventually we all go through it successfully. Thanks.
Thank you. Thank you very much. And Mr. Aaron, any final note from your part, from your enrollment team? Any scholarship opportunity for Bangladeshi students?
Oh, yes, definitely. If you achieve great results, if you achieve an average score of 89% or above in your Monash University Foundation year, or even in your from Diploma Part 2, when you enroll to Monash University in Malaysia, there is a Monash High Achiever Award, yeah, for you with good grades in your study at UCB. So do your best. And if you need advice, if you want more information about further studying, please make sure you visit UCB, speak to my colleague, my counterpart in UCB, Jamal, or anyone, the counselors in UCB, they will help you with that. Thank you so much.
Thank you. Thank you very much, Mr. Aaron and Dr. Amin Talei, for your wonderful presentation and being here and giving your time for our Bangladeshi students. Thank you very much. And participants, for you, I would like to have the pleasure to invite you to visit our campus right here at Gulshan in Dhaka. So this is the first time STS group, you might have heard that group, one of the largest groups in Bangladesh that, I mean, you might have heard about Evercare Hospital, DPS, STS, ISG. I mean, this is a top brand, basically STS group used to work with. Now, this is the first time they have brought another golden opportunity, world top brand, Monash brand, right here in Bangladesh. So it is the opportunity for you to start your Monash University degree journey right after your OAS and A level here in Dhaka while being with your family members. So don't have to take the much challenge of cooking and fooding and other things while staying outside. Rather stay with your family members and start the degree journey, be acquainted with the culture of Turnitin, similarity, other testing. So once you are acquainted with the culture of Monash curriculum, international curriculum like Monash, so it will be easier for you once you start your second year here in Malaysia. So things will be much more easier for you to cope up with the curriculum and other things. So with that note, thank you very much for joining us today. So bye-bye everyone. Happy Friday. Thank you very much.
Thank you. Bye. Have a good day.